Sure it is.
Yeah. All right. Let's see. How about, did we do 11? Looks kind of familiar, but
I think we did. Wait.
yeah, I think we did 11. You got the answer pretty quick. What is it?
It was, okay, EDF is 35 and the measure of EDF is 65. Oh, that's right. It was 80. It
Yeah.
was D. Yeah, we did that one.
Okay. Number 12. I don't think we did. Usually I remember these. Now, this is a very common problem that we get on the ACT. It's what I call an average problem. By
Yes, sir.
average, not average in degree of difficulty, but it's about asking you what averages are.
That's right.
So how are we going to do this?
So we would just, that would be in 3 bowling games, how much you have to do. So it would be 150 plus 190 plus 160 plus X divided by 4 is equal to 175.
Okay, that'll certainly work. That's the
Or do,
algebraic way to do it. But here's what I tell everybody. Average problems are always total problems. You have to figure out the totals. So the easiest way to do this, in my mind, is if she's going to average 175 over 4 games, how many total pins does she need to knock down?
total what?
What's her total score going to be? If she's going to average 175 over 4 games, what is the total score of those 4
Oh,
games going to be?
okay. 700.
Okay. Now, what is she totaled in the first 3 games?
505.
So, what's she got to get on her 4th game?
195.
And
So
that's the
it's
way I always do these problems. I think it's actually easier than setting it up algebraically. But the
yes, sir.
key is to know that when you take an average of something, you total them all up and you divide by the number, right?
Yes, sir.
So when you know the average, you know it's going to be the total of all the scores times the number of events or whatever. All right.
Yes, sir.
Okay. Yeah, now we're getting into maybe middle, medium hard questions. Still not hard. Still questions I would expect you to be able to answer fairly readily.
All right. So
What's the best thing to do here?
you, hmm.
Draw a picture.
Okay, that's what I was. So you would plot it out.
Yeah, sure, because particularly when you plot it out and you see what they're asking, you realize about the only way that you can do it is by looking at it.
Yes, sir. All right. So 0035 and 02.
Make a triangle. Now, answer those questions. Now it's easy.
One angle measure is more than 90.
That's it, right there. No, excuse me, that one. Yeah.
Yes,
Yeah, and you don't have to do any math. You just have to look at your picture, pretty much.
that's right.
All right.
So the solutions of the equation. Okay, so that is y squared minus 2, y minus 3. So,
Straight factor.
that's right.
And notice this one does not set up well for back solving, because they ask what is the sum of the solutions. If they'd have asked which one of these answers is one of the solutions, then you could have just plugged them in and back solved it without knowing how to factor. But in this case, they want to make sure you know how to factor.
Yes, sir. All right, I get J, 2.
Yeah. What do we got? Y minus 3 times y plus 1. So
Yes, sir.
3 and negative 1. The sum of those is 2. All right. Sometimes I haven't worked these through in such a while that I don't remember what the exact answer was. Okay, what are you going to use to do this one?
Calculator, you just
as quickly as possible. There's no thinking involved here. Just convert that fraction to a decimal.
That's right. And that is 0.875.
Okay. Number 16 is the textbook question for the technique of what?
Is there a specific term that this is called?
Yeah, back solve.
There's
two ways to do this. You can try to figure out how to set up the algebra and define your variables, but trust me, you're going to love back solving a lot more. Which answer do you start with?
You would start with either G or J.
Yes.
Is that right?
Yep, that's absolutely right. So let's start with G. It's a smaller number.
Yes, sir.
Okay? So we're going to assume Billy has 20 marbles.
All right.
Now, let's work back through the problem. You do it. How many does June have?
June has 20. June has 40.
And how many does Maria have?
She has 60.
Does that total 100?
That does not.
So what do we know?
So it has to be smaller.
Now, you don't have to do the math. Just choose 15. That's why
60.
back solving works so well. Is because so many back solving problems, you get to the solution and you know instantly whether you need a smaller or a bigger number.
Yes,
Let's
sir.
say that number would have come out to be 80. Well, now you have to do the math on J, and once you do the math on J, you're going to know the answer 100% of the time.
Yes,
It's
sir.
either going to be, you're going to know it's K, or you're going to know it has to be smaller than 30 and bigger than 20, so it has to be H. In other words, the back solving technique ensures that you only have to test 2 numbers, never 5, never 4, in fact, never 3. 2 numbers,
Yes,
2 calculations will ensure that you get the answer. And I love it on questions like marble questions or age questions. In other words, a variation of this problem is Jill is 5 years older than David, and in 3 years, David will be 3 years older than Jim, and problems like that, where you can pick an answer and then plug it in, and you'll know instantly whether you have too big or too small of a number or exactly the right one.
Yes, sir. All right.
Well, my computer is acting a little squirrely. It really is. My Windows doesn't look like it's quite updated. It's having a hard time even bringing up this writing thing.
All right, I get B for 17.
So you just plugged in 6 for X and solve for Y?
Yes, sir.
Okay. That's the way to do it. I'm not even going to check the answer. Another question on parallel lines and transversals. And another question where back solving is not going to help you, because notice they ask you the value of the difference of those two angles.
Okay.
That's far different than asking you what that angle is. If
Yes, sir.
you're just giving you what's the value of P, then you can probably back solve it. But when they combine two of the variables and ask you what's the sum of them or the difference of them, those are not back solving problems.
Yes, sir.
So we need to do it algebraically.
Okay.
Start me out on what equations you can figure out.
Okay, so measure P is 20 less than 3 times measure of Q. What is the value of P minus Q? Okay, so P is equal to 3Q minus 20, and that means that
What other equation?
Q plus 3Q minus 20 is equal to 180. So 4Q minus 20 is 180. 4Q is equal to 200 and Q is equal to 50, which means that P is equal to 130. So that means that it is 80, and the answer is F.
Yeah. You see why that would not have worked for back solving?
Yes, sir.
Because you can't take 80 and plug it in anywhere.
That's right.
So, all right. To be honest with you, I'm not sure what to tell you. This might be the hardest question of the bunch. And unfortunately, every single ACT test I have seen has one question very much like this.
Okay.
And what we have to do is, unless you know the answer, I'm going to give you a couple minutes of information on simultaneous equations.
Okay.
You know the answer, I won't spend the time doing that.
I don't know the answer right now.
Notice how much time this problem could take. In other
That's
words,
right.
the typical way to do it would be to solve that, right? Try to solve
That's
it.
right.
You get an answer. Try to solve that one. You get an answer. Try to solve all of them. That's going to take you about 5 minutes. And then finally, you're going to get to one where you can't solve it. And that will be the
That's right.
solution. But let me give you a couple of scenarios. First of all, when you have two solutions and two equations and two variables, you either have one of three things.
Yes, sir.
You either have an exact solution, or
Okay.
you have an infinite number of solutions, or you have no solution. That's
Yes,
it.
sir.
And that's really what they're asking for here. And the fact that they're asking which one does not have a solution, well, you know that's not the option. In other words, we got to find a set of equations here that does not have a solution. So let's
Yes, sir.
talk about this. If I tell you, I'm just making these numbers up, okay?
Okay.
How many solutions does that have?
That's infinite.
Okay. What if I give you a second equation? How many solutions does that have? That system of two equations and two variables has how many solutions?
Does that still have infinite because it's a ratio?
It still has infinite because this is not any additional information. That's the same equation.
That's right.
So I really only have one equation and still two variables.
That's right.
Okay. Now, let me cross that one out, and let me give you another one that says this. How many solutions does that have?
That has one.
If you try to solve this by elimination,
Oh, wait, it has 0.
equals 1. Whenever you
That's,
get a number equals a different number, that means no
that's right.
solution. There is no values for x and y that satisfy both of those equations.
That's right.
So that's what they're talking about in this problem, is how to identify no solutions. Now relook at all 5 answers and just kind of scan them and see if you can find similarities with what I've written over on the right.
Okay. X plus 3y. All right. I think I found it.
Which one?
E.
Yep. In other words, the left side is the same. It's just everything multiplied by 3. And
That's
the right
right.
side, if that's at 18, and then that would be the same equation. And you would have an infinite number of solutions. The fact that it says any number other than 18 means that this has to be a no solution problem.
That's right.
All right. That's all the time we need to spend on that. I almost hate to spend that much time on that problem because there's only one of them like that, and that's a pretty confusing problem and hard. You have to really understand systems of equations to get it.
Yes, sir.
All right. So I tried to erase all the notes I had written on this piece of paper, so give it a shot here. Tell me how you're going to do this.
Okay. So they're collinear. LS.
Probably the easiest thing you should do is label it up.
Yes, sir.
Now, how detailed do you want to be? I don't know. That's up to you. As long as you can read your own writing, I don't need to do a whole lot. Might not even have to do all of that. Just have to know that it's 50 from L to S.
And then it's 38 from
Yeah, let's put that on top so we don't
MS.
get confused, because that's the biggest problem with this problem is keeping track of where stuff, which dimensions are which. And
how many is LR?
MR.
Okay, well, you can just subtract.
MR, but in fact, I'm not sure. MR, you're actually better off trying to solve this and not labeling MR.
I get J.
Yeah. Okay.
All right.
That's pretty straightforward problem. Yeah.
Yes, sir.
Okay. It's just a question of not making a mistake when you label it up. That's really the essence of that previous problem.
Jeez. What is?
What's the word of mean? O-F.
You multiply.
Okay.
Okay, so 33. So that's just, okay, so.
That's the easy way to do it, is to convert it to a fraction, not use the percentage.
All right.
In other words, 1/3 of t equals 9. So what's t?
So that is, t is 27.
So what's 1 and 1/3 of t of 27?
Is that what that, oh, that's 1, yes, that's right. So 1 and 1/3 of 27 is going to be 36.
Yeah. Now there is a little bit of a shortcut that they're offering people who notice it. And that is that is exactly 4 times that.
Huh. Oh, okay.
And since that's 9, this has to be 36 instantly. In other words, I don't actually have to go through the process of solving for t.
That's right.
All right. No, there's one more. This is one of the 4 trig questions.
D is 1, df is √2.
Here, I'll label.
That's right. And what is the value of the tangent of x? That's going to be 1.
Yeah. Because you recognize this as a 45-45 right triangle?
Yes, sir.
Because of these two dimensions, and so therefore that one has to be 1?
Yes, sir.
Very good.
Don't they say like drawings are not to scale?
Yes, they do. And in fact, this one is not to scale. FE definitely looks longer than DE.
That's right.
So, all right, let's go to the next page. And also, when we go to the next test, we don't need to start at the beginning. I got an idea that starting at maybe number 20 is probably the way to go with you.
Yes, sir.
Okay, this is a good one.
Question and radius and square of the next one. Circumference.
There's always 2 exact questions on conics. And usually they're on circles and ellipses. They don't ever ask about hyperbolas, and they don't really ask about parabolas. But they do ask about circles and ellipses, and you want to memorize their general equations.
Yes, sir.
So what's the general equation of a circle?
Of a circle, that is
Especially
X,
with the center at the origin. That makes it much easier. What's the general equation of that?
so that's going to be x squared plus y squared equals r squared.
Which in this case is 49.
That's right.
Now how are you going to solve this, given that you know that equation?
You can plug it in.
Okay, is that on the circumference?
That is.
Is this on the circumference?
That is 9 plus 4. Yes.
Okay, is this on the circumference?
No.
Okay, that's the way to do it. You have your answer. In other words, that's clearly on the circumference. That's the same as A. And this is on the circumference. Square both of those, you get 26 plus 23 equals 49.
That's right.
So everything on this problem stems from you knowing that general equation. Okay? That's the general equation when it's at the origin. This is the general equation when it's not at the center. They will definitely ask you questions that they're not always going to be at the center. Okay?
Yes, sir.
This is H and K are the center.
That's right.
It's that H and K were both 0 in the top equation.
Yes, sir.
Okay, as long as we're talking about it, what is the general equation for an ellipse?
That is x minus h quantity squared over a squared, or is it just over a?
No, it's over a squared. You're going to
Over a
numerator
squared.
and denominator in all of these.
And then y minus k quantity squared over b squared
Now,
is equal
yeah, go ahead.
Is equal to 1.
Okay. Now, the only difference is the a is not always under the x. Sometimes it's under the y.
That's right. It's under
the x when you have this kind of an ellipse. But if you have a vertical ellipse like this, where your major radius is on the y-axis, whereas this major radius is on the x-axis, when it's this, you have to have a under the y. In other words, the major radius has to be under the variable that it's
on.
Okay. So the only difference would be this would be b squared and this would be a squared. And their a always has to be bigger than b, although I'm not sure you ever need to know that.
That's right.
All right, number 24. I have no idea what it's doing at number 24, but
all right. points A and B of integral coordinates in the standard xy coordinate. What is the product of y coordinates of A and B integral oh, the y okay, so that's -12.
Good.
That was a weird problem.
Well, weird easy, right? Given that it's question number 24, it should be in the tough part. So you got to take that with a little bit of grain of salt. Apparently it's not always. In other words, you might find an easy question on question 50. That's why it's so important to make sure you look at all questions, because you can't assume that it's just the first 20 that are going to be easy. And,
that's right. Okay.
Have we done this one? This one has a familiarity to it.
Let's see if we have points BC allowed. And if BAC is a right angle, what is the measure of angle Y? Okay, so that's a right angle. That means that B is also 46. That means that's 44. So that means Y is 136. I don't think we have done this one.
Okay. Yeah, that's correct. Let me just point out perhaps a little bit easier way of doing it. We know that this angle is the same as C. And we know that C is the same as Y. So all we have to do is figure out that angle. We don't have to even look at B. In other words, we don't want to look at this angle over here. That gives us a lot more calculations to have to do.
Yes, sir.
And they've tricked it up by adding this other transversal. In other words, if they would have made the problem just be this,
yes, sir,
it would have been much easier, because we know that that angle equals that angle. But they put an extra angle in there, but it's a 90-degree angle, so it's easy enough to add 46 to 90 to see what that angle is.
Yes, sir. I got 3. That is -27 plus 18, so it's -9. That is -15.
Good.
RST, URT.
Oh, that's a great one.
Plus RT plus RU minus ST plus SU.
What's your first inclination?
Oh, okay. It is D.
Very good.
Because that is a factoring problem.
Yes, and you're factoring out a binomial term.
That's right.
And it's very easy to get off track here. If your first inclination is to distribute that, you end up with RT plus RU minus ST minus SU, and then it's so much harder to factor that into the correct answer.
That's right.
In other words, you want to use the easiest factoring method, which is to factor out the greatest common factor from the original expression, as opposed to most people, their first step here is going to be to distribute it, and it just makes the problem harder then.
Yes.
Okay, number 28. I don't think the answers matter. I mean, they don't help. Let's see, if I draw this up, AB is 8. BC is 6. And DB is 4. And they want to know the area of the small triangle.
So is that just going to be 6?
Yeah, this, and also DF is parallel to AC, which is a vital part of the answer.
That's right.
Yeah,
Because it shows
in
they're
other
similar.
words, that's got to be a midpoint, and that's got to be a midpoint. So we know that that has to be 3. And now you
Because
have to figure out the area of a triangle that's got a base of 3 and a height of 4, which is
so because it's parallel, they are similar triangles.
yes. Because they're similar triangles, all of the proportions and ratios are the same.
That's right.
Yeah, and they're similar triangles because that angle got to be equal to that angle from the parallelness, and this angle's got to be equal to that angle. So you got two
That's right.
triangles that have the same 3 angles. Makes them similar.
Yes, sir.
It's the fastest way to do this one.
Calculator.
Maybe.
Oh,
Not so sure I agree, but go ahead, do it in your calculator, see how long it takes you to come up with the answer.
or would you just find the
I would do it based
whatever?
on my knowledge of the unit circle, but I teach the
That's
unit
right.
circle every day, so I'm not
So
sure
that
you're going to be able to do it as fast that way. What quadrants is it in? Let's not use the calculator for a moment.
that's in the third quadrant, and it is a 45-degree angle, which means the cosine is going to be negative, so that is negative root 2 over 2.
Perfect. Now do it using your calculator.
Yes, you're right. It's negative 0.70710, and you don't really know
No,
what
then
that
you
is.
have to figure out which of those answers is equal to that. Is it that one or is it this one?
That's
No, it's
right.
not negative a half. In other words, you can eliminate it to A and B, but still, it requires actually more math to use the calculator than to use your knowledge of the unit circle. If
That's
you have
right.
that knowledge, and it looks like you do. And
Yes,
I'm
sir.
pretty confident you do. You are very good on the unit circle, I remember.
Yes, sir.
All right. That's the level of difficulty of the trig questions on this exam. So don't go
Okay.
spending any time learning advanced trig for this test.
Yes, sir.
Okay? One answer is missing. But again, the answers aren't going to help here. You're not going to back solve this. So all the information in the stem is on the drawing,
Okay.
except the area. The area is 45.
Units, how many units long is YS? Okay, so that is oh wait a minute, hold on, I did that wrong. So that is
Start with that right there. What's the
it
base?
is G. It is 6.
Okay. What's the base?
The base is 15,
Okay.
and then you get 3, and you multiply it by 2.
Yeah, now it's easy. Once you get that general formula, I am such a believer that you start pretty much any math problem with the general formula if you can. And
That's right.
just plug in everything you know, and usually there's only one thing you don't know, which is what
That's
they're
right.
asking for. So, okay. Collinear, do you know what that means?
They're on the same line.
Okay.
Circle C and D are points in circle C. O D are collinear.
You need the general formula for circumference.
Circumference is 2 pi r.
What's R in this case?
R is going to be 5, so it's 10 pi.
Another one that doesn't look like it belongs in this section.
That's right.
All right.
Maybe a bit earlier down on the test, maybe.
32. When you first look at this, is this a hard problem or an easy problem? Just
I
look at
guess
the problem, look at the paragraph, look at the answers. Hard or easy?
Easier.
It's actually easy. In other words, what I'm trying to point out is that,
Okay.
man, they give you the surface area of a right cylinder. Who the heck knows what that is? I'm confused already. That doesn't have anything to do with anything.
Okay.
So all that is a greatest common factor. Which of the following represents an equivalent expression as that? So take out the greatest common factor from that function.
Pi and r.
Okay, so pi r times what's left over?
Pi r times s plus r.
Right there, k.
And that's k.
Yeah.
Yeah.
And notice you didn't have to know it was a right cylinder. You didn't have to know what surface area is. This is just a straight question of what's the greatest common factor on this function.
That's
You could
right.
have asked it like that, and you would have said it's an easy question. When they ask it like
Okay.
this, they try to fool you into thinking it's a hard question. It's a pattern. They definitely give you information that is irrelevant to the problem. So you have to kind of assume that you're going to run into problems where you're going to be given information that is not significant. You don't need to use. What's the slope of that thing real quick, fast as you can?
That is
Don't solve it all out.
-5/3.
-5/3. Very good. In other words, the y-intercept is not important. So there's no need to solve that equation for y. Is all you have to figure out is what's the coefficient of x going to be when you move x on the other side.
That's right.
And it comes down to that and only that. Oh, incidentally, I don't know if I told you this or not. That one question that I was concerned about that had to do with this.
Yes, sir. Okay.
Well, that's not quite true. We're taught in math that that is true.
Okay.
It isn't if x is negative and y is negative. However, it is if x and y are negative, then that has got to be a positive number. So you can take the square root of it. And in other words, remember we had a question where it was saying, you know, both x and y can be positive or negative. And I was a little concerned with it because by the time you turn it into that, now x and y cannot be negative. But when it's the start, it can be. It's a little bit like logs. In other words, they give you these rules on logs and they tell you that the log of a times b is equal to the log of a plus the log of b. But that's not exactly true. Notice that if a and b are both negative, then this argument becomes positive and you can take the log of it. But if a and b are both negative, that is not true. You cannot take the log of a negative number.
That's right.
So you got to be a little careful with these rules you learn in math. They not always mean that this thing is identical to what's on the other side of the equation. As long as you're not dealing outside the domain, in other words, with imaginary numbers, then it is. But when you start dealing with taking square roots of negative numbers, you got to be a little careful. Same thing with logs. Exact same thing.
Yes, sir.
If I'm checking the answers and seeing whether it passes the domain test, I do not use what's on the right. I use this only. That is the only true way to test whether your answers satisfy the demand or the domain.
Okay.
Now I've covered up the question enough that now you can still read it. How are you going to answer? Check all 5 answers and see if you can make them not true. And if you find one that you can't make not true, that's the answer. In other words, let's check F. Okay.
All right.
What can you make A and B? In other words, picking numbers. The third technique to answer these questions. There's the algebraic solution, there's the back-solving solution, and there's the picking numbers method, where you pick numbers for A and B. Can you find a number for A and B where this is not an integer?
Do we want to try 7 and 3?
Or even 7.5 and 2 3/4. It doesn't say anywhere where they have to be integers, A and B. So A and B can be fractions. So no, there's no way that this thing is an integer.
That's right.
Okay, so I can cross that one off. Now, it is positive if B is greater than A. Is that true?
Yeah.
Kind of is on the surface, but it's a trick question.
Okay.
What if B... It is positive if B is greater than A. Maybe it's not a trick question. Maybe I'm remembering it wrong. That does seem to be the answer, I think, because that's got to be a positive number, and that's got to be a positive number. When you add 2 positive numbers, you get positive. So I'm thinking that's it, but let's just check this. It's always positive. No. If A is 2 and B is 11, then it isn't positive. Yes, it is. If A is bigger than B, then the square root of B minus A you can't do. So no, it's not always positive. In other words, B has to be bigger or equal to A.
Yes, sir.
And I thought that was the trick part of this question. It is negative if A is equal to B. No, what is it if A is equal to B? It's 0, right?
That's right.
Okay, so that's not it. It's always real. No, if A is bigger than B, it's not real anymore. It's imaginary. That's what makes imaginary numbers is the square root of negative numbers. So it's not always real. So by process of elimination, you can show that B has to be greater than A. But I'm not even sure you need to do the other 3. Once you find G, and yes, you cannot find any numbers that don't make that positive.
Yes, sir.
All right. Oh, this is a good one too. Take a look at your answers on this one, because sometimes the answers help you. Not in the sense that you're going to back solve it, but it's going to show you what they're trying to get you to think. When you solve a quadratic equation using the quadratic formula, what does your answer look like?
You're going to have...
Looks like this, doesn't it?
That's right.
Only what goes in place of the minus sign?
A plus or minus.
Ah, so the other solution is the plus end of this.
So it's E.
Yes, that's the fast way to do it. The slow way to do it would be to actually figure out what the 2 solutions are. In other words, use the quadratic formula. And it will give you E as the other one. But the first thing it's going to give you is 7 plus or minus root 17 over 2. In other words, it's by looking at the answers, it reminds you that, these all look like solutions to the quadratic formula. Well, I know what that has to be. It's just change the sign instead of a minus sign.
That's right. All right.
And they want to know what it is.
So that is 20 divided by the square root of 2.
Okay. Now that answer isn't on there, so what's the most likely reason it isn't?
That is, oh, it's not rational.
Actually, the answer is on there. It's just in a better form. What's wrong with this answer? You're never going to see that answer on a test.
It is not rationalized.
Okay, so rationalize it.
So that is going to be 10 root 2.
Yes. Okay. You're doing pretty good on these, Garrison. What was your last score when you took the ACT test for the math part?
When I took the official ACT?
Yeah, do you have a score on record that you've taken it for your timed conditions and stuff?
The real ACT, the one that I took in the 7th grade.
Well, that's right. You took it late.
I think.
Wow.
I think the score was like, well, I can't remember the score on the math, but the overall was like, I think a 21 or a 22.
It's awfully good for 7th grade. I think 23 is average for
That's average.
For high school juniors and seniors. 23 is average. And you scored 22 as a 7th grader? Yeah.
21 or 22.
Yeah. Well, I would expect you to score in the 30s. The top score on the math is 36. I'd be surprised if you don't score a 30 on the math or above. And 30 is 99th percentile.
Wow, 30 is 99th?
Yes.
Good grief.
The reason I know is because I had a student that scored a 30, and I put up that information on my website. I showed his test score.
Wow.
Well, he was a really smart kid, but he'd been diagnosed with a learning disorder.
Wow.
I think just ADHD. I say just, but he had been diagnosed with that. So they gave him, not only was he really smart at math, but they gave him an extra 30 minutes on the test because of the learning disability. And yeah, which I find interesting. And perhaps unfair to everybody else taking the test, but nonetheless, that's the way they do it. How about this one? 37.
All right.
Oh, incidentally, do you want to go for a full hour? Yeah, we're only 5 minutes away from a full hour, so you're all right with going a little later?
We might as well do the full hour.
Okay, cool.
All right. For all A, 3 minus 4A is equal to, okay. So that's always going to be 3A squared plus 6A minus 4A. So it's going to be plus 2A. That's going to be C.
Okay. In fact, you notice you don't have to do the last number.
That's right.
Once you get the first coefficient and plus 2 on the second coefficient, you're done. You don't even need to multiply minus 4 times minus 2 or times plus 2. And another thing to notice is they always put this stuff in front. Why? Why don't they just say, what is 3A minus 4 times A plus 2? That's what they're asking. So kind of learn to ignore all of those little for all A's and for A's not equal to 0, stuff like that.
So it's just meant to distract you.
Kinda. I mean, yeah, I think that is why it's just meant to distract you. Now, sometimes if you have like x divided by y, mathematically, they do have to say for y not equal to 0 because you don't divide by 0. But there was no dividing going on in that problem. It was all multiplication, so we didn't need to know for all A.
Okay.
That's kind of assumed. All right. This is another common problem they have where in other words, the easy midpoint problem is when they give you the two ends, right?
Yes, sir.
If I give you here, I'm going to give you one. If I give you these two ends, What's the midpoint?
So the midpoint is 7.
Add the two numbers and divide by 2. That's what you're always doing.
3.
Okay. Now, they make it slightly more difficult because they give you the midpoint and they give you one end. So if I didn't have that, how would you get it?
You would multiply the midpoint by 2. Is that right? You would
Adding, you're just adding, not multiplying.
In
other words, take the difference in, what's the difference in the x coordinates?
That is 6.
Okay, so I have to go in that direction 6 more units. I'm going to the right, right? When I go from 1 to 7, I'm going to the right on the x-axis. So I have to keep going the same distance, which gets me to 13. And do the same thing on the y-coordinate. I'm going from -2 to 3. So I'm going from bottom to top. And I'm going +5, so I add 5 to 3 to get 8.
Okay. So it's k.
Yeah. Exactly. Now, this 39 is kind of like a marble problem and kind of like an age problem, which would suggest that we would want to use back solving. But then when we look as to what they're asking for, the sum of the 3 numbers, well, that's not going to be a back solving problem. If they were asking us for one of the numbers, that's a back solving problem. But the sum of all 3 of them, you can't just pick an answer and go back through. So let's figure out the 3 numbers. What's the first number?
Number's the second number. First number is going to be.
What are we going to call it?
S.
Okay. What's the second number?
Second number is that 5 less than 4 times?
I think it's 3. It's 3 less.
3 less.
Mm-hmm.
Okay, so that's 4s minus 3.
And the third number?
Third number is 2s plus 5. Which of the following represents the sum of the 3? Okay, so that's just 7s plus 2.
Yep.
E.
And always just start with the first, write it out. The key here is really figuring out what to call the first number. Oh, and they even tell you if S represents the first number. So we didn't have to figure that out. They told it to us. So this actually is a super easy one. It's a little puzzling how many easy ones they have in the difficult sections here. Let's do one more. Let's do 40, a nice round number we can remember.
All right. In the figure below, PQ intersects A, B, C at points E and D. B measures 80 degrees. SAB measures 130 degrees. CDQ measures 110. What is the measure of?
All of that information is already in the diagram.
That's right.
So we don't really even have to read anything except figure out the angle that they're asking about.
Okay, so if CDQ is 110, that means that CDE is 70. So that's one angle of that small triangle. And then if ABC is 80 and SA, wait, if SAB is 130, that means that angle A is 50. And if angle A and angle B are 50 and 80, that means that is 130, which means that angle C is 50.
Okay, one shortcut. Let me remind you, I know you know how to do the rest of it now.
Yes, sir.
Remember, an exterior angle is always equal to the sum of the 2 angles that it is not supplementary with.
That's right.
Okay?
I'd forgotten that.
Skip this step here, even though it wasn't a long one. It doesn't hurt you to do that step. but every little second that you can save gonna pay off in the long run.
That's
So
right.
you can immediately get angle C, and then angle, the one they want is easy from there. All right. We shall stop at question 40 on test 1 and pick it up next Tuesday.
Yes, sir.
Talk to you then. Have a good week.
You too.
All right, Garrison. Bye-bye.
All right. Bye.